While the pilot flying sets up the flight management system and navigation systems, the pilot monitoring can take this moment to set up the aircraft systems on the overhead, main, and pedestal. Let's begin on the overhead panel. The leading edge devices should have their lights tested with the test switch to ensure that none of the lights are burned out. The inertial reference system has already been spun up by the pilot flying. The service interphone, connecting maintenance personnel on the ground to the cockpit interphone, should be in the off position unless it's desired to be used. The dome light is self-explanatory and can be used in either the bright or dim positions to illuminate the cockpit. The engine panel should be inspected for a lack of reverser lights and electronic engine control fail lights, and also to ensure that the electronic engine control switches are on and guarded. Crew oxygen should be at 1000 psi or greater, and the passenger oxygen switch should be in the guarded normal position. Selecting this switch to on will deploy all of the PSU oxygen masks in the passenger cabin. The flight data recorder can be tested by moving the test switch from normal to test and observing the off light extinguish. The test is completed by closing the guard and observing the off light illuminate. The Mach airspeed warning test, both left and right, can be tested, as well as the stall warning test, or stick shaker, on the left and right yoke. The number 2, or first officer stick shaker, should be used for more than 6 seconds, as the vibration on the right side of the cockpit helps reset the spoiler control module in the pedestal. Keep in mind that these tests will not be available until 4 minutes after AC power has been applied to the aircraft. Moving to the forward overhead panel, the flow can be moved through fairly logically in columns down the panels of the forward overhead. The flight control switches should be down and guarded, and the yaw damper placed to the magnetically held on position. This switch can only be placed on if the IRSs are in alignment and have completed their built-in check. The nav and display switches should be in the normal and auto positions. The engine valve and spar valve closed lights should be dim blue. The engine crossfeed closed. All fuel pumps should be off unless a forward left tank or center left tank pump are being used to run the APU. The electrical panel has been previously discussed in the electrical power-up procedure. The cabin utility and in-flight entertainment switches should be turned on. Both generator drive lights should be illuminated, and the IGG switches verified in the closed or connected position. Disconnecting an IDG from its respective engine is an irreversible procedure, and the generator can only be reconnected to the gearbox by maintenance. Both GenAlf bus blue lights should be illuminated, and the wipers in park. The circuit breaker and panel light switches are self-explanatory. The equipment cooling fans, both supply and exhaust, should be in their normal position. There's an alternate fan, again, both supply and exhaust, that can be selected by moving this switch to the alternate position if the primary system fails. The emergency exit lights should be armed, with the guard closed, and the fasten seatbelt lights turned on. The window heat should be turned on at this time. Of note, the green on lights will only illuminate if power is actively being applied to a window. In hot climates like Phoenix or Las Vegas in the summertime, it is perfectly acceptable for the on green lights to remain extinguished. They will only illuminate if the required window requires heat. Once the window is heated, either electrically or by the sun, power will be removed to the window. Probes can be left in the off, or in this case, automatic position. Newer NGs and Maxes generally have an auto position, whereas older NGs typically have an off position. Wing and engine anti-ice switches should be off, and the hydraulic system should be configured with engine-driven pumps on and electric pumps off. The doors panel reflects which doors on the aircraft are currently open. Forward entry door is expected. Left and right overwing emergency exit doors is a symbolism from PMDG. I've never seen these lights illuminate in the actual aircraft, but PMDG simulates it as a matter of normal operation. These will extinguish once the aircraft pressurizes on the takeoff roll. The cockpit voice recorder can be tested by pressing the test switch for 5 seconds and observing a green light. The pressurization panel contains gauges for cabin differential pressure on the outer scale, cabin altitude on the inner scale, and the cabin VSI. Just verify that these gauges make sense. In this case, no differential, cabin altitude of 0, and a cabin VSI of 0. Note, in Salt Lake City or Denver, the cabin altitude gauge may be at around 5,000 feet. The voice recorder switch should be in automatic, the trim air selected on, and the cabin and cockpit control knobs for temperature can be in the auto position. Of note, a 600 and 700 variant 737NG will have a different ECS layout than this. The left and right recirc fans should be in the automatic position, and this bleed air panel is configured correctly for an aircraft with a shutdown APU. Engine bleeds should be on, the APU bleed off, the isolation valve open, and the pack switch is off. Consider this a smiley face and a frowny face. We'll discuss the bleed air panel more in depth later in this tutorial. The cabin pressurization system should be set to the cruise altitude as well as the landing altitude for the trip, and the pressurization mode selector should be verified in automatic. The lights panel can be configured with logo and steady position lights, while the anti-collision light, wing light, and wheel well inspection lights should be off. The engine start switches, both left and right, should be off, and the ignition system should be selected to right for the first flight of the day, and then subsequently to the side of the pilot flying. Left ignition if the captain is flying, and right ignition if the first officer is flying. The reason for selecting the right ignition on the first flight of the day is because the right ignition system is powered by the standby bus, and we want to verify that the right ignition works on standby power prior to operating the aircraft for the day, in case we lose primary AC electrical power. The APU is off for right now. We'll start that as boarding commences. And the landing lights, runway turn-off lights, and taxi lights are also off. The EFIS mode control panel can be configured per each individual pilot. The altimeter should be set with the barometric knob, and the minimums can be used to set a minimums bug for instrument approaches. Bearing pointers for VOR1 and VOR2 can be selected on or off, and the navigation display, or ND, can be cycled between approach, VOR, map, and planning modes. In addition, arc, centered, or centered with a VSD, vertical situation display modes, can be selected with the center push button. We'll use the VSD during the descent, but for departure, we'll use arc mode. The range knob is self-explanatory, and further data can be selected to the ND with the weather radar, station, waypoint, airport, data, position, and terrain knobs. These can be configured per the pilot's preference, but for right now, ensure that the weather radar is selected off on both sides. The mode control panel can be set, accomplished by the pilot flying as part of their procedure. Simply verify the flight director switches are turned on, left and right, and that the master light appears over the pilot flying's flight director. The master light is controlled by whichever flight director is powered first. The lights test switch should be switched to test, and a quick second to be taken to verify that all the lights in the cockpit illuminate correctly. If a burned out bulb is found, spare bulbs are located above the first officer's crew position. A quick note: every light in the 737 can be tested individually by pressing it. This is simulated correctly in the iFly 737 MAX, but not in the PMDG. Continuing from the lights test, we can gauge the standby attitude indicator, ensure that the standby altimeter is set, and reset the fuel flow. The N1 and speed reference bug knobs should be in the automatic position, allowing the FMS to control the bugs on the navigation display and the engine instruments. If for some reason both FMS CEUs fail, these knobs can be used to set the data on the ND as well as the PFD. The MFD knob, or switches rather, should be selected to engine, and the oil quantities, in this case 18 and 19 quarts, verified against a minimum of 12 quarts. The hydraulic system page should be checked, with the quantity indicated below 102%, which is an overfilled condition, and above refill, which is an underfilled condition. Select the auto brakes knob to RTO. Observe the disarm light appear and then extinguish as the built-in test is completed. Verify that brake pressure is 3000 psi, and test the GPWS, or ground proximity warning system, by pressing the switch momentarily. If this switch is held, an extended test is entered, which is generally not performed by aircrew.
Glide slope. Pull up. Wind shear. Wind shear. Wind shear. Terrain. Terrain. Pull up.
Airspeed low. Airspeed low.
Once the GPWS test is complete, verify the speed brake handle is in the down or stowed position. The parking brake is set, and we'll check the takeoff configuration warning horn and its activation with both the left and the right throttles. To do this, simply individually advance the left and right throttles to takeoff power and verify that the takeoff configuration warning horn sounds, as the aircraft is not correctly configured for takeoff. This check will be accomplished again as part of the before takeoff procedure, except at that point we are not expecting the horn to sound. The flaps should match the gauge position, in this case up. The engine start levers should be in the cutoff position. The stab trim cutout switches should be in normal. And at this point, we'll execute a fire test. Even if a fire test was completed as part of the electrical power-up to start the APU, we must execute an additional fire test now that we have AC electrical power on the aircraft. To execute the fire test, simply clear the master caution system by pressing the master caution light, and starting with the left test switch, cycle the switch to fault in up. We should see both left and right master caution lights, an overheat detector caution, an APU fault detector light, and a fault light. Now take the switch, move it to the overheat fire position, and we should see 2 red fire warning lights, 2 master caution lights, an overheat detector master caution, an engine 1 and engine 2 overheat light, a wheel well fire light. The number 1, number 2, and APU fire handles should illuminate as well as unlock. That's a good fire test. Now take the squib test switch, move it to System 1, and ensure that the green lights for the left, right, and APU squibs illuminate, indicating continuity. System Test 2 is accomplished the same way. The fire test is complete. Moving down the pedestal, the nav radios have been set for the air return, and the comm radios should be set to the airport frequency. The fire test can be accomplished by pressing the test button and listening for a fire bell, as well as a forward and aft warning. The radar can be tested by pressing the test switch and observing the test pattern on the display. The transponder should be set to standby with the correct code entered, and the rudder trim should be tested by running it left and right and verifying that the index moves against the scale on the pedestal. Aileron trim should be tested left and right, and the aileron trim verified with the pointer on the yoke and the scale on the control column. The final step of the pilot monitoring pre-flight is to test the oxygen mask, as well as the autopilot, autothrottle, and FMS lights. This concludes the pilot monitoring pre-flight for the 737NG. At this point, the pilot monitoring would verify the pilot flying's work on their own FMS. While the pilot monitoring accomplished this, the pilot flying would verify the flow that we just accomplished was completed, ensuring two-person integrity over the entire pre-flight procedure. I'm going to go ahead and review the work in the FMS, and then we'll come back and load nav data and get ready to start the engines.